Can electronegativity differences predict bond polarity? Interesting question. Let's get down to it. Now, electronegativity, by definition, is the attraction an atom has to, we'll say, to shared electrons in a bond. So if we're talking about electronegativity, we have to have an atom that has to at least be in some type of bond, whether it's an ionic bond or a covalent bond, right? So maybe we'll just do a covalent bond. Covalent bonds are between two nonmetals. Now, it doesn't really necessarily matter who it is. Maybe I'll just say, X and Y, but it's good to give real-life applications. So let's do, let's do hydrogen and let's do fluorine. And we have a bond here, right? Now, in essence, if we look at the space in between that bond, now just remember that a single bond, which is represented by one line, a single bond represents two electrons. So there are two electrons in this bond. And maybe one of the atoms, maybe hydrogen or maybe fluorine, has an attraction to the shared electrons in that bond, meaning that maybe the electrons are split evenly right down the middle, 50-50. That means that no one atom in this case is more greedy than the other. However, if fluorine is a little greedy and it's got more of an attraction, fluorine's like, come closer to me, little electrons. Or on the flip side, maybe hydrogen's the one that's more attracted to these electrons, and hydrogen is able to pull the electrons closer to its atom. So whenever you're thinking about bond polarity, polarity is a fancy way for saying there's some type of pull, which means that an atom in a bond is more greedy than the other. And it turns out that in order to find out if there is any pull or any polarity, the only property that can determine that by looking at these bonds, because we are talking about bonds, so it is a chemical bond, the only property that can do that is electronegativity, to see that attraction. So in this case, electronegativity values, they're just ratios, right? They have no units. And it turns out that actually fluorine is the most electronegative element. Whoop. You don't really have to know the specific numbers per se, but I would definitely remember the trend that if here is my periodic table, well, would it be? Oh, that's actually a pretty good periodic table. And here's my electronegativity box, right? Just know that electronegativity will increase as we go across a period, and it will also increase as we go up a group. So the most electronegative element is fluorine, which is in group 17. The least electronegative element is francium, which is all the way in the bottom left. So basically, electronegativity is increasing from francium all the way to fluorine. And since fluorine is the most electronegative, it's going to have the most attraction toward those shared electrons. So it's going to pull those electrons so close to its own atom, basically leaving hydrogen to nothing. So to answer this question, what do you think? Can electronegativity differences predict bond polarity? You are absolutely correct. The answer is yes. The difference, by the way, is just taking each electronegativity value and subtracting it. So for example, hydrogen is 2.2 roughly, and fluorine is the most, which is 4.0. Electronegativity differences is when you subtract them, and then you just see, do you have a big number? Relatively, do you have a big number or a small number? Do you have a 0? And that can determine whether there would be a pull. So the answer here is yes. And that's it. Hopefully this helped. Thank you so much for viewing the video. Let me know in the comments if this helped you out. I love hanging out with you guys, and I hope you're doing well out there. If you want more practice like this, you could head on over to our website, glazersguide.com. The link will be in the description, as well as the end of this video. You can click the link. It will transport you to a magical world of practice problems where you get to hang out with me. You get to hang out with me and Andrew, and it'll be fun times, right? Because we're learning and we're having fun, and we're going to be crushing those exams and quizzes. So let's go. Proud of you guys. Keep working hard, and I'll see you on over at the website, all right? Okay, bye-bye.
For more practice and for more fun, go to glazersguide.com.
And for more practice and for more fun, come on, go to glazersguide.com.